Hello, we're continuing in section 3.3 where we're talking about quadratic functions in vertex form. Now you should have already completed the Desmos graphing activity below, and after you do that, there's things up here that I want to make sure that you understand what it's saying, because this is here to help you. All right, so first of all, this is vertex form. We have something in the form of f of x equals a, and then in parentheses, x minus h, all squared, plus k. And h comma k is where we find the vertex. And we compared all of those graphs that we had to the parent function of f of x equals x squared, or y equals x squared. So now it just kind of summarizes what happened with it, right? So let's think back on what happened with the h value. Well, it represents the horizontal shift, right? How far left or right is it moving your parabola? Well, if h is subtracted from x, the parabola shifts to the right h units. If h is added to x, it shifts the parabola left h units. So it kind of is maybe opposite of what your brain is thinking is going to happen there. That's the one where he said insiders or liars. Okay, what about our k value? Well, our k value here is what is doing our vertical shift. It's shifting it up or down. And so if k is positive, it shifts it up. If k is negative, it shifts it down. And then the a value does a lot for the graph, right? There's a lot of things it does. And so it is determining whether it's opening up, whether it's opening down, or if it is stretching it or compressing it. So if a is positive, the parabola opens up. If it's negative, it opens down. Okay, but if the absolute value of a is greater than 1, then there's a vertical stretch, and the parabola appears to be narrower than the parent function, right? You can see the graph of it is narrower. But if the absolute value of a is between 0 and 1, so it's a fraction between 0 and 1, there's a vertical compression that takes place, which makes it wider, right? If you're compressing it vertically, it's making it wider. And so if we're comparing it to that parent function again, we can see that it's wider. All right, one other thing that we need to make sure that you understand too is about maximums and minimums. So it refers to either the highest or lowest point of the parabola. So if we have an upside down parabola, then the vertex up here is going to be the highest point of the graph. And if we have a right side up parabola, right here, then the vertex is going to be the lowest part of our graph. Okay? Another thing to keep in mind is that a parabola always has symmetry about the vertical line that passes through the vertex. So you can see as you look at your parabola, it's a mirror image, one side and the other. If you were to fold, like cut it in half and fold it over, it would line up right on top of the other. And that's called the axis of symmetry. We're going to be talking a lot about that going forward. So make sure you understand that part. Now let's go ahead and fill in a summary here. So let's see if we can fill this in without having to look back up, right, with what this is. So the vertex is located where? At what point? Right, so let's write this as an ordered pair. Well, h was our x value that was moving it left or right, comma k is our y value that's moving it up or down. Right, so we're trying to figure out like how far over and how far up or down that's going to be moving it. Right? What about the equation of the axis of symmetry? Well, in the definition, we said that vertical line, the line of symmetry, is going through the vertex, right? And it's going through the vertex at what that x coordinate is. So that means that we have a line, and you need to write it in an equation form, right? So we're going to put anything that is a vertical line is an x equals. And x equals whatever that h value is. Right? So x equals h. All right, so the equation of the axis of symmetry, make sure you write this as an equation. And remember that when we draw vertical lines, they are x equals some number. Well, what is that number? Well, whatever our x coordinate is in our vertex is going to make that line, that axis of symmetry. Right? So if A is positive, the graph will open up. If A is negative, the graph will open downward. And then if absolute value of A is greater than 1, the graph will appear narrower. And then if it's between 0 and 1, right, if that's a fraction out in front, then it will appear wider. Okay, I hope that was helpful in reviewing all the things that we talked about in these previous videos.